Welcome everyone. So in the last part of last unit, we found out that for negative half cycle, the transition state occurs at Vi is equal to minus 1.4 volt. And we found out since the diode appears to be oriented in anti-clockwise directions, so that means for the value of signals above the transition state line, which is Vi greater than minus 1.4, the diodes are for reverse biased or off, and below the transition state line, which is less than minus 1.4, the diode is on for the voltage or for the value of the voltage on the signal. And then we found out the interval. So between T by 2 to T3. So during this interval, and also in this interval, T4 to capital T, so in this interval, we found out all the value of the signal is above the transition state line. All the value of the signal is above the transition state line. So therefore, during this interval, the diode is off. However, between T3 and T4, so in this interval, T3 to T4, all the value of signal is below the transition state line. So that means if you pick any point on the signal, so all the value of the signal is below the transition state line, which is less than minus 1.4. So that means diode is off. So now we're going to determine the input output relationship for when the diode is on and the diode is off. First of all, let's do it for off. So for that, let's redraw the circuit, assuming the diode is off. So this is our D3, D1, R. Okay. So that means the current that is flowing through the diode I equals to 0. V naught is equal to 0. So which means during this interval and this interval, diode is off, output voltage is 0. So it can be drawn like this, okay, 0. And then let's find out what happens when the diode is on. So on input output relationship when the diode is on. When the diode is on, we can replace the diode. So since we know that the Vi is negative, so we can already put the symbol. Vi is negative. So we know that. So dealing with between T by 2 to T, where the input signal is negative, so we already put the signal negative. Okay. And let's say the current is flowing always from positive terminal to negative terminal. The real current always flows from positive terminal to negative terminal through external circuit. So this is the direction of the real current. So the voltage V naught. So this is the minus. Now if I apply KVL, then we get minus VI plus 0.7 plus V naught plus 0.7 equals to 0. So that gives us V naught equals to VI minus 1.4. So this is the relationship between, since we have already selected, we already know the polarity, it's negative half cycle. So all we are going to consider here is a magnitude. So V naught is equal to VI minus 1.4. So then now it's going to draw the circuit. It's already at T3 and T4. T is equal to, sorry, at T is equal to T3 and T4, we know VI is equal to 1.4. Now you might ask the question, why I didn't select VI is equal to minus 1.4 instead of 1.4? Because we already know that we are in fact in the negative half cycle. So we don't need to additionally add another sign for here. So we know we have to only put the value. So if I plug the value here, V naught is equal to 1.4 minus 1.4, which is 0. So this way we found the value of V naught is 0. And then so we are going to find out what's happening at the maximum at VI max. We know that it is VM. Again, why we drop the minus sign? The reason we have dropped the minus sign, although we are dealing with the negative half cycle, is that because we know that we are already in the negative half cycle. So this relationship that we have obtained, considering this is in negative half cycle. So that sign has already been considered here. Okay. So that's why we don't need to separately select a sign for any value to select any value. So now if I put the value of VM here, so we're going to get V naught max is equal to VM minus 1.4. So that gives us some positive value. So that means when I draw it, we get this. So that means whether you select for positive half cycle or for negative half cycle, the output is always in positive direction. You see, we obtain the same relationship when when for positive half cycle, V naught is equal to Vi minus 1.4. So another way we can show this, that see, for positive half cycle, so this is the direction current is flowing. This is the direction of the current. And for negative half cycle, current is flowing in this direction. So notice the current through the resistor for both positive half cycle and for negative half cycle flowing in the same direction, which is from right to left. So therefore, for both positive half cycle, so both half cycles, voltage drop polarity is plus minus, also plus minus. So it doesn't matter which direction the current is flowing in other area when it is positive half cycle and in negative half cycle, but the current always flows from positive terminal to negative terminal when it's flowing through the resistor. So therefore, the corresponding voltage like that. So now, so this is finally we come to this relationship. So you see, if we summarize all those things from 0 to T1, for positive half cycle, diode is forward biased, D2 and D3 is forward biased, D4 and D1 is reverse biased, and positive half cycle, we have a transition state which is Vi is equal to 1.4, and we found out this green region is on and the red region is off. So in that case, the output is this one. When it is reverse biased, a transition state occurs at Vi is equal to minus 1.4. In that case, below the transition state, diode is on. The green region indicates the diode is on. And above the transition state, the red region indicates the diode is off. And since for both half cycle, when the diode is on, V naught is equal to Vi minus 1.4. It is for positive half cycle. Also for V naught is equal to Vi minus 1.4 for negative half cycle. So therefore, our value is always positive. So that is how, and the peak is Vm minus 1.4. So in that case, average, we are going to have an average value. It's a DC again. The average value, VDC, or V average, we can determine in the same way that we learned in our last class. It is, so Vm, it comes around 2 into 0.318 times Vm minus 1.4. So you notice this is twice as much, considering for half wave rectifier. So this is a full wave rectifier circuit.